Hello and welcome. In this video, we are going to look at the standard code structure used to develop Amplenote plugins. Amplenote plugins must ultimately be loaded as a single JavaScript object expression containing specific lifecycle methods or command configurations. However, writing your entire plugin in a single monolithic file makes it hard to maintain, test, and reuse code. To solve this, this repository uses a modular structure, separating the development code into clean, testable ES modules and then bundling them using a post-processing pipeline. Let's walk through how this is laid out. High-level directory overview. Looking at the root of the project, we see several important configuration files and directories. 1. esbuild.js. This is the heart of the build system. It takes our modular ES code and compiles it into a single file object expression. 2. lib directory. This contains shared templates, utility functions, and mock frameworks that can be leveraged across all plugins. 3. anp_xx name directory. Each plugin has its own folder, prefixed with anp and a number, e.g. anp01 timestamp. This directory is self-contained and isolates the specific business logic, documentation, and tests of that plugin. 4. package.json and configuration. Files like eslintconfig.js, jestconfig.js, and jsconfig.js configure linting, testing, and editor auto-completion consistently across the entire project. The plugin directory structure. Inside any typical anp directory, you will find anp_name.js, the main entry point file, lib directory, subfolders detailing specific categories of functionality, such as formatting utilities, regex replacers, or external API callers, tests or test directory, a dedicated testing directory containing unit tests, usually with the suffix .test.js, build directory, the directory where the compiled outputs are generated, documentation, standard files including readme.md, code documentation.md, and designphilosophy.md. The entry point file. Let's look at the main entry point file at the root of the plugin folder. Its primary role is to configure and export a default object conforming to the Amplenote plugin API. Instead of implementing helper functions directly in this file, it imports them from the internal lib directory. The export typically exposes Amplenote plugin interfaces such as insert text for inserting text at the user's cursor, replace text for replacing selected text, note option for running commands from the notes action menu. By keeping this file limited to imports and exports, the entry point remains highly readable and clean. The lib directory and modular helpers. Under the plugin's lib directory, helpers are grouped logically. For example, formatters houses modules that format dates, times, or custom text styles. Replacers houses modules for parsing text and replacing substrings. Each utility is exported as a standard ES module. This modularity means we can write small, isolated functions that do exactly one thing, making them easy to unit test. The build system and bundler logic. Since Amplenote requires a single object expression, how does our modular ES module code get transformed? When you run the build system, ESBuild parses the entry point file. It follows all the local imports inside lib and bundles them. A custom resolver wraps raw object expressions in standard exports so ESBuild can process them cleanly. The build script performs post-processing. It wraps the entire bundled output inside an IIFE, immediately invoked function expression, that returns the main plugin object. This encapsulates all code, preventing global variable collision and allowing complex functions and helper classes to exist safely inside the scope. The output is written to the plugin's build directory as a compiled JavaScript file, ready for distribution. Testing setup. Testing is managed using Jest with support for ESM. Inside the tests folder, you will find files matching the pattern anp_name.test.js. These test files import functions directly from the source code and run assertions. Since the logic is modularly separated into helper files, we can test individual functions thoroughly without needing to mock the entire Amplenote editor runtime. Local development workflow. To run builds and tests locally, we use simple terminal scripts defined in the root package.json. Running the build command packages the code. Running the test command executes the Jest test suite, showing you code coverage and test status immediately. This developer experience ensures that plugins remain stable and easy to maintain over time. Conclusion. That covers the standard structure of the ANP folders in this workspace. By isolating each plugin, structuring features as modular ES imports, and utilizing a post-processing bundler, we achieve a modern developer experience while complying fully with Amplenote's runtime constraints. If you have any questions, feel free to leave a comment below. Don't forget to like and subscribe for more developer guides.